What's going on, everybody? Welcome to my channel. Today I wanted to talk to you about an interview question which most of the companies ask, and you actually can't find the proper explanation in any of the websites, and I think this is a major problem. So the question is, if you are a programmer and you know data structures and algorithms, in some companies they ask you that what's the difference between static and dynamic array. In most of the languages like C++, Java, C#, there are two different types of arrays. One is the normal array and the other one is the dynamic array. You can push new elements into dynamic array and you can't do any operations, just can change the variables in static arrays. So they ask you that what's the logic behind the array list or vector in C++. So actually it will go like this. If you search online for some explanation, every website will told you what's written in here. A fixed array is an array which size or length is determined when the array is created and allocated. So static arrays are easy. It has a fixed length and we can just change the variables in it. So the dynamic array is, if you read the explanation here, it just says that they have a limit, they have overcome the problem with fixed capacity with static ones, and you can push new elements to it, and as well as delete new elements. Also delete an element, insert an element at a specific position you want. So but what they don't tell you is, we'll talk about it later. So let's look at different implementations in different languages. In C++, an array is created like this. This is a static array, by the way, and they are really similar. And if you want to use a new dynamic array, there are some different implementations of it. You can use list or vector in C++, list in C#, and array list in Java, as you know. So, but what is the logic behind array list? How does it work? For example, how does it push new elements to it? Actually, it has a kind of weird implementation, and let's see about it in code. So I'm going to write with C++ here. If you create a vector and this vector has a fixed size now. It has a fixed capacity, it's not unlimited. And you can check it with couting its capacity. For example, cout v.capacity, and let's print a new line here. As you can see now, it has a capacity of 0. But if you push a new element into it, for example, let's push 1, and then let's look for its capacity again, it will say 1. And let's push a new element to it again, and let's look at its capacity again. It will go to 2. However, if you do the same operations again, you'll see that its capacity is 4. So it doubles every time. What does this mean? Actually, dynamics arrays are created with the help of static arrays, but it has a class definition, a class reference, and it has some functions in it that handles the complexity. Actually, it will go like this. You can actually, in both C++ and Java, array lists any dynamics array actually have a fixed size. And when you start pushing new elements to it, that fixed size changes and it always doubles. And you can reserve a wanted amount if you want in C++, and it will go like this. For example, if I say v.reserve, for example, let's reserve 100, 1, 2, 3. Let's reserve an array that has a maximum capacity of 1 million, okay? And now, if you try to cout its capacity, you will see that it has a capacity of 1 million. Okay, so now let's begin to push new elements into it. So for int I equals 0 and I is smaller than 999999, 999999, I plus plus, and I'll just push some random placeholder value, for example 10. Alright, so now I've imported a time module here to calculate the time between every pushback. You'll understand why I did this in a minute. And in C++, let's create cure time. It will go like this. You'll just write clock and enter. And if you want to know what time is passed between two commands, it will just go like this. Let's push a new element into it, and after pushing, let's print out its capacity. So far so good. And after this operation, after just one pushback operation, I'm curious how much time has elapsed. And I will do it like this, double clock minus curve time divided by clocks per second. Clocks per second. And let's print a new line here. So this code is just simple. It subtracts the current time before the 15th line and divides it by clocks per second to get a time elapsation based on seconds. Okay, so let's run it now. As you can see, now we have a capacity of 1 million, and in one pushback operation, time elapsed is 1.4 10 to the minus 5. So really small time. It's like milliseconds, or actually microseconds. However, if I just copy and paste the code here, and let's try to run this again. So I just push back 10 two times, and if you do this, as you can see from this code, in the first pushback operation we had a capacity of 1 million, and one pushback operation just took 2.7 10 to the minus 5, really small amount. And after this operation, after the next capacity, we see that our capacity is now 2 million. So it means that our 1 million capacity is now reached, and C++ created a new array with the size of 2 million, and now the pushback operation took a really long time compared to this one. So why is this happening? Actually, they want you to answer this question, and actually it's easy, but you can't find any reference here, so I'm telling you all about it. When your fixed array size, both in Java and C++, if it is reached, it creates a new static array. Okay, so everything is done with static arrays. Actually, you just don't see it. And at that static array, the capacity of it is doubled. Therefore, this 1 million sized array went up to a 2 million sized array, and now this array is empty. So C++ copies all the previous elements to the new array. That's why this took this much seconds. So the 1 million sized array that we are using before is now all copied to the new array, and the other one is just deleted. That's why array lists are actually made from normal static arrays, but some helper functions and the guys who wrote the libraries overcome this problem by creating always double size if the pushback operation is greater than the capacity size. If there is an interview, you can just tell it about this like this. Therefore, all the array list operations, if the capacity is reached, are copied to another array, and also the capacity is doubled. So see you guys in the next tutorial. Take care, guys.